Hey guys, this is Mike. In this video, I'm going to go over the very first example, blank window in Orion Dev. I'm going to go ahead and open it. The blank window example is kind of the bare bones simulation that simulates nothing program. And this is a great example to go over the bare basics of our simulation software and just point out what everything does. So hopefully all you remember that 2 slashes are comments. So comments do absolutely nothing in our program. They're just there for us. The first line that's not a comment is an include, and this includes gk12.hpp, which is the whole system for drawing graphics, for getting keyboard input, for getting mouse input. These 4 lines here are variables that control our window. I'm going to go ahead and run this program. The first one is the window title, and that is the title of your window. So on top of this editor here, it says main.cpp acopad. On the window I just created, it says blank window here. So that's just the title of your window. The background color is the background color of your window. So I have a nice gray here. The colors go red, green, and blue, and they range from 0 to 1. So if I change this to 0.8, I'm going to have 0 green and a little blue. So this is a little bit of red, no green, and a little bit of blue. I don't know exactly what that'll do, but we'll see here in a second. And the last 2 lines here are the width and height of our window. So this window is 640 by 480 pixels. I'm going to change this to 300 by 300. 640 by 480 is kind of a standard. It doesn't have to be any numbers close to that. It can be square like it's going to be here in a second. So that's kind of a purple background, right? So a little bit of red, a little bit of blue should make purple. After those 4 lines, we have 3 functions: setup, loop, and draw. Setup, we'll just initialize our values here, our variables, all that stuff. Loop is a little more complicated. Loop happens as fast as possible on your CPU. And the difference in this loop and in Arduino's loop is that it doesn't have this DT right here. And that DT is really important because on our computers, we're going to run this code on a bunch of different computers. It's not going to be just your computer. It might be on my computer. It could be on someone else's computer. And because of that, all these different computers will have different CPU speeds. So on the Arduino, it's okay if we don't have DT. And DT is change in time, because all Arduinos run at 16 megahertz. But in our computers, some might run at 2 gigahertz, some might run at 3 gigahertz. It depends on your computer. And if we don't have DT, our simulations are going to go faster or slower on different computers. So DT is change in time, and when we multiply different variables like speeds and velocities by DT, they'll be constant on all computers, which is really what we want in a simulation. I mean, if you're playing Battlefield 3 on your Xbox, you want it to run at the same speed as it would on your friend's Xbox. And finally, we have draw, which is where we draw stuff. And there's a kind of a graphics industry standard of you only draw stuff in the draw loop. You never do any keyboard input. You never update any variables. You only draw in the draw loop, which is not super important on 2D graphics because our graphics cards are so fast that 2D graphics, it doesn't really matter. But if we were to do really advanced 3D graphics, drawing and loop happen at the same time. One's on your video card, one's on your CPU. So if you want to draw stuff really fast, you only draw in the draw loop. So that's pretty much the whole blank window example. Next time we'll get into drawing some basic shapes and maybe drawing some images on the screen. If you have any questions, I'll see you guys in class. I'll see you next time.